All right. Okay, are we recording? We are. I think we're recording. Right here. Okay, good. I think we're recording. Let's start this recording right here. What's going on, algebra students? Let's get this party started. My hair is getting really long. I don't know why I just noticed it now. Anyway, can you hear my voice? All right. And then, can you see my face? Awesome. Then let's get this recording started. Let's do it. So to be honest with you, Poly 4 was actually I think it's pretty simple. And I think it's pretty fun. Let me do Poly 6, and this one was a little bit funky for you guys. Let me explain to you what's going on. If I asked you to factor this thing, like 5x squared plus 2x plus 3 equals 0, or let's make it equal to 7. How would you do that if I asked you to factor that? You guys know? Just say no, or I don't IDK, or yes I do, and tell me what you would do. Okay. Well, let's see. I definitely wouldn't do what Sophia suggests. All right, no. There's a formula for this, and the formula looks kind of like this. Ax squared plus bx plus c equal to 0. So we need to take that 7 over to the other side and then make it equal to 0, and then we can basically apply this equation. And it was that negative boy who was unsure about a radical party. It was kind of a square missed out on 4 awesome chicks. Party was over at 2 a.m. You guys remember this? Yeah? Okay, yeah. So we have a formula. It's called the quadratic formula for factoring these things. I mean, ideally, we want to just be able to break it down like this, you know, x and all of that kind of stuff. But when all else fails, we do have something that will always work, which is the quadratic formula. Right? You guys remember this game that we played? Here's the problem, is we have a formula for doing things that look like this, but we don't have a formula for doing things that look like this. Or above that, actually. You see, we have no way of being able to really factor this. And to be honest with you, I can't even think of a formula that I can give you that will really help with this process. There's a few special cases, but not a general formula like the quadratic equation that's really powerful. So what we're going to do right now is we're going to learn how to factor those kinds of functions. And the way we're doing it, the approach we're taking is this long division route. And you guys are wondering, what does long division have to do with factoring? And oh, you still, even after I explained it to you, you still hate this long division stuff? I don't feel like it's really that bad. Okay, all right, well, maybe we'll try a few more of these problems and see what we can do, all right? I'm going to take 4x cubed plus 2x squared minus 4x plus 3. Okay, so write down the problem, and that equals to 0. I think, yeah, no, it doesn't equal to 0, it's just there. There's your equation. I can even say f of x equals to that, okay? And then let's try this. Ideally, I would want to be able to factor this down to something that looks like this, right? Where I have an x and a number, an x and a number, an x and a number. Where if I were to multiply it all out, that would be really, that would turn back into this thing. So Genesis, what you missed was I have this, say I have something like this. And I want to graph that in my head. I want to graph that. I don't have a graphing calculator. So if I were to make it into this form where I have three different things that I would have to multiply together, I could graph this, right? This is easy, has been easy to graph. The hard part is turning it from this into this. If this were an x squared, and that was the biggest term, then I have a way of factoring it easy, quadratic formula. The problem is there is no formula for a cube or a fourth power or whatever. So we're going to turn to this trick called long division. Let me show you folks what I'm doing here. What I'm doing here is I'm saying, okay, well, what happens if I don't know all three of those parentheses, but I knew one of them? Okay? Say I knew what one of them was. Then what I can do is I can say, well, let me figure out what's left over. Say I knew one of them for sure. Well, what's left over? Okay, let's say that one of them was 2x plus 3. So what I'm saying here is 2x plus 3 times something on the right-hand side is equal to this top thing. Does that make sense? And I want to figure out what this thing on the right-hand side is. So to me, that sounds like division, right? If you have something times something equals a number, or equals whatever, then you need to be able to, or you would divide this here and you would figure out what that is. And Sophia, I'll tell you where I got 2x plus 3, not right now, but just let me go through the justification of long division and explain each step. It's really not that bad. And then we'll talk about how we got that. It's pretty easy. Cool? All right, so what I'm going to do is I'm going to set it up like a long division. So I'm going to say I want to take this number, I want to divide it by 2x plus 3. Okay? Can you see? I'm just going to erase this and write it a little lower because you can't see because of this glare up here. 4x cubed plus 2x squared minus 4x plus 3, 2x plus 3. Okay, I'm just going to erase this. All right, make sure you're writing this down. Okay, you ready? All right, I'm going to start off with the 2x. And I'm going to ask myself, what do I have to multiply the 2x by in order to make it into 4x cubed? 2x squared. There we go. Perfect. Yeah, no, that makes sense. 2x times 2x squared gives me 4x cubed. Does everyone see that? All right. Then what I do is I multiply the 2x squared into here, into the number in front. And remember, you got to distribute that 2x squared to everything. So 2x squared times 2x is 4x cubed. And we're happy with that. And then 2x squared times 3 is 6x squared. Does that make sense to you? Okay. Then what we're going to do is we subtract, right? So what I like to do is I like to subtract, but you need to make sure that you're subtracting everything over here. What I like to do to be safer is just to put a negative out in front, and that's my subtraction. In fact, to be especially safe, what I really like to do is add, and I put a negative in front of each of the terms. I change the signs, because that's being very careful to add the negative, so I know to subtract this and subtract that. Cool? I'm only being careful with this because if I put a minus in front of there, you would think only to subtract the 4, but not the 6 as well. All right, so I subtract this way, and then this is 2x squared minus 6x squared gives me negative 4x squared. And then this is 4x cubed minus 4x cubed, so that's just 0. Are we cool with that? And then we go through the steps again. We basically rinse, wash, and repeat. So what do I have to multiply the 2x by to give me 4x squared? 2x squared. No, just 2x. Actually, negative 2x. Right, because I want to multiply the 2x to get negative 4x squared. So I need at least one x, that's why I have one x, and I need a negative 2 because 2 times negative 2 gives me negative 4. All right, now I'm going to take this negative 2 and multiply him into this thing right here. Right? So then we go negative 4x squared minus 6x. Genesis, do you understand where I got the minus 6x from? Okay. I had a feeling you didn't, so that's why I asked you. Right. I took the negative 2x and I multiplied it here. I basically took my 2x plus 3, that thing, that's this part in front, and I multiplied him by negative 2x. So when you do that, you have to distribute to both of those. That's why I have negative 4x squared, because that would be negative 2x times 2x. And I also have the negative 6x, because negative 2x times 3 is negative 6x. Does that make sense now? It's just the same steps of long division. You're just, I think the only difference is you're distributing now. Oh, I forgot to do this, we also have to drop down that number over there. So minus 4x. Are we cool with that? All right, now I'm going to subtract this bottom one, but what I like to do is add a negative, so I'm going to just change the signs on all of these and add them. So, negative 4x plus 6x is 2x, and then this is 0. Genesis, do you understand why I changed the sign on these? Sophia, do you? Why did I change the sign? They were negative 4x squared minus 6x, but I changed the sign. Yeah, because I'm taking into account that I'm actually supposed to be subtracting it. So I like to just change the sign on everything and then add them. It's the same thing. Yeah. All right. I'm going to drop down that 3. And then I'm going to say, well, what do I have to multiply 2x by in order to get 2x? 1. So I'm going to say plus 1. And now I'm going to take the 1 and I'm going to put them over here so I have 2x plus 3. Because 1 times 2x plus 3 is 2x plus 3. Make sense? And then, of course, you subtract the bottom one. So subtract and subtract. This is 0 and this is 0. So we're good. There's no remainder left over. Do you understand each step that we did? All right. It wasn't that hard. I mean, I'll go through it with you slowly. Or I mean, again, a little bit quicker. All we did was we wanted to take this thing and we divided this whole thing by this thing. And so we just looked at the first term in here and we said, what do I have to multiply 2x by in order to get 4x cubed? Well, that would be 2x squared. So then we, basically cycled through this, subtracted it, dropped things down, long division. It's the same thing, yeah. On the course. Yeah. I have videos from me doing this last year, but I'm doing this again this year. Okay, so I would almost venture to say, can I erase this? Is that all right? The work? I need more space. Okay. Don't worry, I'm recording this. So what I'm saying here is I would almost venture to say that 4x cubed plus 2x squared minus 4x plus 3 is equal to 2x plus 3 times 2x squared minus 2x plus 1. So that's kind of how I started this game. As I said, it would be great if I could turn this into 3 different parentheses. Let's say that I had one of them. There we go. What would the rest of it be? And we figured it out. It's this thing up here. Does that make sense? Okay. Now, can we break this thing down even more? Sure we can. And how would we break this thing down even more? We could try factoring it. But even if we couldn't factor it, and I'm going to try factoring it, I'm going to give it maybe a couple minutes to try to factor it. But even if we couldn't factor it, I'm still not scared of it, because if all else fails, I can turn to the quadratic equation, and that will factor that thing for sure. In fact, I almost want to just do that right off the bat. Oh, you already got it. Okay, fine. All right. I'm going to put a 2x and an x over here. And then I'm going to put a -1 over here. And a -1 over here. Will that do it? I'm just trying to factor this thing right here. Oh, because I need to multiply out to be 2x squared. Not an x and an x. I need to multiply it out to be 2x squared. To be honest with you, I don't think this factors very nice. I don't think I can do it. Yeah, it doesn't work. So why don't we just try taking this thing and applying the quadratic equation? That will help us. I mean, the numbers don't come out nice, but it sure as heck will work. I promise you that. All right. Quadratic equation on that would be 2 plus or minus the square root of 2, let's see, that would be 4 minus 8, that would be 4ac, all divided by 2. No, all divided by 4. Oh, wait, we got a problem. This is 2 plus or minus square root of 4 of -4 over 4. So that would be 2 plus or minus 2i over 4. So it's 1/2 plus 2i, or 1/2 plus 1/2 i, and 1/2 minus 1/2 i. You guys see what I did? Those are my two factors. So what I do is I take my two factors and I just say, oh, well, this thing actually broke down, and it didn't break down very nicely, but it's x minus this factor and also x minus this factor. Does that make sense? Wouldn't we be setting is equal to 0 to get rid of the term, the a term? No, you wouldn't be able to do that. You can't get rid of the a term in this particular one. I'll be honest with you, maybe I should have done a different problem. And I'll tell you what, I'll do a different problem. Let's see. Let's just do this one. Here. Let's do this one. Maybe this might work out nicely. Hopefully it does. All right. Let me show you when the numbers come out a little bit nicer. Okay. So, what we would do is we would say this. Let's try this one. X cubed minus 6x squared plus 11x minus 6. Okay. I don't have any way of factoring this thing down. But what if I were to tell you that one of the roots root is at x equals to 1. What if I were to tell you that this graph crossed at 1? In fact, let me try to kind of graph this. I know it's a cubic function. And we looked at the graph and say that it went like this. And I noticed that, hey, x equals 1 is one of the roots. You guys see what I'm doing here? So then what I say is, okay, all right, then what is the rest of the roots? What are the other two? If I knew one of them, what are the other two? Well, we can figure that out. So by telling you that a root is at 1, what can you tell me about this parentheses in here? What are one of the factors of that parentheses? What would go in here? X minus 1. Did you say x minus 1? I can't see that. Yeah, exactly. Because if one of the roots is that positive 1, then what goes in the parentheses is always the opposite of, the opposite sign, x minus 1. So here's what I want to try to do, is I want to figure out what the other two pieces are. Got it? So we would use long division again. And it's not bad. X cubed minus 6x squared plus 11x minus 6. Long division, x minus 1. Okay, so Bradley, you just showed up. I'm going to kind of make sure that you answer these questions too. What do I have to multiply x by in order to make it x cubed? X squared, good. Okay, so I'm going to multiply everything over here by x squared. I got x cubed minus x squared. Are we cool with that? Genesis, do you understand why I got the minus x squared from? Yes, Bradley, yes, absolutely. We subtract now. I'm going to put a minus here and a plus here. What I did was I changed the sign of everything in here, and now I'm going to add. And so instead of subtracting, I multiplied through by negative 1, and then I added. I'm going to add. Does that make sense? Okay. So this plus this is negative 5x squared, and this plus that is 0. So what do I have to multiply x by to make it negative 5x squared? Negative 5x. Perfect. No. Actually, Bradley, you're right. I'm sorry. It's... Oh, yeah, no. Sophia, you were right. It's negative 5x, right? Because you need another x to balance that out. Yeah, perfect. All right. So I'm going to make this negative 5x squared plus 5x. You understand why I have plus 5x? Look at it closely. Okay. Yeah, there we go. I forgot to drop down this 11x. And then I need to make sure to multiply this by negative 1 and add them. So essentially I'm subtracting them. So this becomes positive and negative. Now I'm going to add them. So 11x minus 5x is 6x, and this is 0. If this doesn't come out to 0, that means you forgot to subtract. Because the whole point was to get rid of this. Right? And then we rinse, wash, and repeat. We will go through the same thing again. So we say, all right, well, what do I have to multiply x by to make it 6x? Just 6. Then you have 6x minus 6, and then I can drop down this negative 6 over here. And I subtract these, and so I get 0 left over. So I would venture to say that x minus 1 times x squared minus 5x plus 6 gives me this on top. Do you guys see that? All right. And then I would do this. Okay, can I erase this long division? Is this long division hard? No, I don't think it's hard. It's definitely not as hard as chemistry. I can tell you that. All right, I'm going to erase this long division part. And then what I'm going to do is I'm going to say, well, what if I factor this a little bit more? Can I do that? All right, let's try it. X. I'm thinking -2 and -3. Will that do the job? Yeah, I think that works. Okay, so here's what I'm saying. What I did was I took this equation and I actually broke it down into 3 parentheses, and that's a good thing because now I can graph this. I can say, here's my graph, and the graph crosses at +1, +2, and +3. Here, here, and here. Where is the y-intercept? Close. It's actually at -6. Because if you plug in 0 in for all the x's, you have -1 times -2 times -3. 3 negatives makes a negative overall, and you have -6. So I would venture to say that your graph looks like this. Here's what I want you to do, and I'm not going to do it because I have the camera screen on, but you guys can do it. Open up a new tab and plug this into Desmos. X cubed minus 6x squared plus 11x minus 6. And do me a favor, if this ends up being the correct graph, go back to the chat bar and say, oh, wow, that's so amazing, Mr. Daldig, you're so cool. I'm happy, I'm excited because this thing actually did work, or, be excited about it. So double check my work. I want to see if my graph that we made off the top of our head, we didn't even use a calculator or anything, actually worked. I predicted that what the graph was going to look like before you actually checked it. Plug that sucker into Desmos and tell me what you get. I'll give you a second. It worked. Awesome. Did everyone? Cool. So is this cool or what? Is this like, wow, now this is like, I can see how long division is actually useful and used. And that's it. That's why I taught you that's why you learned long division back then. And really, it's not hard. It isn't hard at all. It looks big. There's a lot of steps to it. But these steps are easy, and you just kind of repeat the same 3 steps each time. I bet you that the thing that will screw you up, if it screws you up at all, is subtracting. Everyone screws that up. That's why I do my add negative. That's why I do it. And also, just being organized. If you're unorganized, this just stuff becomes hard. But it's not hard. It's just you're unorganized. We cool? All right, let's do another example problem. Yeah. I'll do one more, and then I'm finished with Poly 5. We can move on to Poly 6. All right, I'll do it. Just always keep track of, just keep track of what you're doing and when you're doing it and why. And I'll tell you what, if I wanted to, I could FOIL out all 3 of these things, and I will get back there. In fact, I kind of have a feeling, I think I remember somebody emailing me saying, how do I FOIL all 3 factors like this? Let me do it real quick for them. just because I remember they asked me that in an email and I never got back to them. So I'm going to explain that right now. If I wanted to, I could double check my work in factoring this by multiplying all this out and seeing if I get the right answer back. So I'm going to take this right here, x minus 3, x minus 2, and I'm going to FOIL that. Foiling, actually, you know what? I'm going to do the first two ones. It doesn't really matter which order I do it in, as long as I do all of them. Foiling is just first, outer, inner, last. So x times x, that would be x squared minus 2x minus x plus 2. Parentheses. And I still got my x minus 3 out here. Combine like terms, so I have x squared minus 3x plus 2. I still got these guys on the outside. Now, here's the thing that maybe might be funky for people is how do I deal with this now? And essentially, you just kind of think of it as distributing. You want to make sure that every term in here is distributed to every term in here. So you want to take this x and multiply him in to each of those. Let's do that real quick. X cubed minus 3x squared plus 2x. I just multiplied everything in here by x. And then what you want to do is you want to subtract, because that minus right there. I like putting a big parentheses to remember to subtract everything in there. 3 times everything in here. So let's just go through this and multiply everything by 3. So I get 3x squared minus 9x plus 6. And be careful, I actually multiplied everything by positive 3 because I already took the subtraction into account there. I'm going to get rid of the subtraction off my parentheses by just changing the sign of everything in here. So now I can drop that parentheses. And I'll combine like terms. So I've got x cubed minus 6x squared, because negative 3x squared minus 3x squared is negative 6x squared. And then I've got plus 11x minus 6. Is that the same? Yeah, it's the same. Awesome. So I factored it correctly. This is just me double checking my work. Sophia, I saw your comments and I'm sorry it didn't work. I'll go through and fix it again, but I'm going to do that after class. You know what I'm going to do is I'll just go through and give everyone credit for that question. No, I'm not going to do that. I think it'd be best if I just fixed it, because that one's not due for a while now. Or I don't think it's due. When is it due? That one's due like next week, right? So people haven't gotten to that yet. All right, anyway. Any questions about this? It's not hard. Yeah, it's actually, I like this stuff a lot, actually. Okay, you know, I'm surprised, but they didn't give you an example problem that had this property, and I was kind of surprised about that. Yeah. Okay, all right. I'm not gonna do another example problem because I think that we did a lot of them already. All right, I'll do one more. Let's say we have 2x cubed minus x squared plus 4. I want you to write this problem down. Actually here, I'm sorry. This is what I want you to write down. Negative x squared plus 2x cubed plus 4. All right. In order to do long division, you have to do some prep work first. Okay? I can't just straight ahead long divide this thing. Oh, and I want to divide it by 2x minus 1. I can't just go ahead and straight ahead long divide this thing. I have to put it in order from biggest to smallest. By biggest, I mean the exponents. So it's 2x cubed minus x squared plus 4. And then you can do the long division. So you don't want to use that. You want to rearrange it so that it's from greatest power to smallest power. The other thing you need is this, and this is where I'm surprised they didn't give you a problem like this. We have x cubed, we have x squared, and then we have x to the 0 power, but there's something we're missing. And x to the first power, I agree. And this doesn't work unless you have x cubed, x squared, x 0, or x to the 4th, x cubed, x squared, x, and then just a number. So what we do, and this is a trick that we use, is we say, okay, well, I can add an x by just putting plus 0x. Does that make sense? And you can kind of think of this 0x as a placeholder. It holds the spot for that, number to go in there, or that variable to go in there. You're not actually changing anything. You're just adding a 0 to kind of like put a space in there. Are we cool with that? Okay, I'm going to erase this, and I'm going to do a problem very similar to this one. This is the actual problem they wanted us to do. 2x cubed minus x squared minus 8x plus 4. I was just worried that you would have never seen something where you needed to add a placeholder and it would have messed you up. So I made sure to talk about that. But this is the problem we actually wanted to take care of today. Okay, all right, so I gave you the factor. It's 2x minus 1. What I could have told you is I could have said, well, like let's pretend I didn't give you the factor, but let's say I say, here's the graph of something, and it crosses, one of the roots is that x is equal to 1/2. Now, this is actually saying the same thing. Do you see it? Because if I told you that this was the root right here, 2x minus 1, and I set that equal to 0, and I solve for x, that would be 2x is equal to 1, and then x is equal to 1/2. So what I could have done is I could have, instead of giving it to you like this, I could have just said, one of the x-intercepts is at x equals 1/2. And then from that information, you would have to be able to figure out what you're dividing by. I tell you, one of the roots is 1/2. Well, that means in the parentheses you need 2x minus 1. Does that make sense to you? Okay, be careful with that. I mean, it's pretty easy if you say, all right, fine, if you told me that x equals 1/2, then what I could do is I could just multiply up 2. So I have 2x equals 1, and then 2x minus 1 equals 0. And hey, that's what needs to go inside that parentheses. All right, let's do the long division. It's not really that hard. Let's just go through it step by step. We'll see what happens. All right. Do you mind if I do it kind of quickly? Okay, stop me if you're confused at any step, all right? What do I have to multiply 2x to get 2x cubed? I need an x squared up there. Distributing that x squared, I get 2x cubed minus x squared. I subtract this down, so I change the signs in there. This becomes 0, and this becomes 0. Oh, hey, this is interesting. Okay, fine. What do I have to multiply 2x by to get 0? Well, 0, I guess. Interesting. All right. If I distribute that 0, I'll get 0 and 0. Or 0 minus 0, really. I'll drop this guy down over here, and this becomes negative 8x. I want to subtract them. It doesn't really matter because I'm just subtracting 0. So really I have negative 8x over here. And then 0 minus 0 is 0. This is an interesting problem. Do you guys see this funny business in the middle? I mean, to be honest with you, I didn't expect that off the top of my head, but I'm just going to roll with it. I'm going to go and follow my steps. All right. What do I have to multiply 2x by to get negative 8? Well, that would be minus 4. Correct? Distribute that thing in there, and I get negative 8x. Negative 4 times negative 1 is positive 4. I got to drop that positive 4 down over here, subtract this, you end up getting 0. Oh, cool. So, I would venture to say that if you gave me 2x cubed minus x squared minus 8x plus 4, I could break that down into 2x minus 1 and x squared minus 4. Interesting, huh? Okay. Well, then what we can do is we can say, that's pretty straightforward. I can break this thing down. Do you guys know how to break this one down? X squared minus 4. Yeah, exactly. There we go. X minus, so really this is 2x minus 1 times x plus 2 times x minus 2. So if it's all right with you, and I'd like for you guys to check this on Desmos for me, but I would venture to say that the graph probably looks something like positive 2 intercept, negative 2 intercept, positive 1/2 intercept. The y-intercept is at positive 4. I would venture to say that my graph should look something like this. I might not get it perfect, but I hope I get something close. Why don't you guys Desmos that sucker and tell me if I'm got even close. Works again. I have to leave at 2. Yeah, I see that, Bradley. Sorry you have to leave at 2. I'll try to make sure I finish definitely before 2. Cool? You'll miss chemistry class, though, but, yeah. All right. Yeah, well, that's the power behind doing this. Do you understand why we're doing this long division and all of that kind of stuff? It's pretty awesome. I think it's awesome. All right, cool. I'm going to erase this. Yeah, I think that all of polynomials has been really nice to us. I feel like it has. And it's interesting. It's interesting to me, at least. All right. I'll tell you what. Let me try teaching you what I know about Let me try teaching you everything I know about chapter 6, Poly 6, which is actually, I think this is where it all comes together. In fact, the chapter is called Putting It All Together. Okay, cool. Okay, fine, let's do this. I wonder if I can, let's do this one. Okay, here we go. So, I'm going to do a problem. I'm going to do this problem. X cubed minus 3x squared minus 3x plus 1. Oh, I'm sorry. Let me write that again. X cubed minus 3x squared minus 3x plus 1. I'm going to say f of x is equal to. Okay. So, what Chapter 6 is all about is basically using all of the skills that we've gathered from Poly 1, 2, 3, 4, and 5 and putting it all together into one awesome ability. I basically want to know everything there is to know about this graph. All right, what is the degree? It's 3, okay? So if it's to the cube power with a leading coefficient of 1, draw a sketch of what you think the graph might look like. Draw an ugly sketch. It's a cubic that slants upwards, something like this. Right? If it were a negative, it would be going down like that, but it's cubic going positive. I'm going to erase this, but all right. What is the end behavior? Tell me about that. End behavior. There we go. It would look kind of like this, right? In the middle could be something weird, but on the left side it'd be going down, and the right side would be going up. And you know they're going to go in opposite directions. How come? How come you were able to tell me right off the bat it's going in opposite directions? Because the degree of the polynomial is odd number. Good. If it were an even number, it'd be going in the same direction. And then if this were a negative leading coefficient, then instead of doing this, it would be doing this. Make sense? Okay. What is the leading coefficient? One. Okay. Can you have fractional degrees? Yes. But I don't think, I know we've covered them actually, but I don't think you're going to get too complicated fractional degrees. I'll explain to you what fractional degrees are in just a second. What are the number of zeros? And I shouldn't really say what are the number of zeros. I should say, okay, you guys say it's equal to 3. I would say possible number of zeros. Because it could have 2. It could also have 1. It could also, actually, it will never have 0. But it could have 2 and 1, for sure. Right? So it's not guaranteed that there are 3 roots to this function. But it could have up to 3. It can't have 4. I guarantee you that. Yeah, it's a maximum of 3. So I think that would probably be more accurate. They literally said, what is the number of zeros? And I would say, what is the possible number of zeros? What is the maximum number of zeros? Right. It has to have at least 1 because it's a cubic function, so it has to somehow cross down like this. But it could go like this, where it only has one root. Right? Now, if it were a quadratic or something similar, like to the 4th power, it would look like this. And then there's a possibility of not having any roots. But I disagree with you, Sophia, in that a cubic function has to have at least 1. Sophia, how's the video? Can you see me? Okay, I think that maybe you just have to log out and log back in. Sorry. All right. What else do we know about? Oh, what is a y-intercept? That's actually really easy to get. Yeah, it's 1. It's basically, you plug in x equals 0, well, that kills everything up here and just leaves the 1. All right, good. I'm going to draw a sketch of the graph. This is, I'm going to graph this, just a very rough version. Okay. What are the roots that you see? you see one root at -1. I can verify that. Yeah. The other root is at like a half, maybe. I don't know. It could be. It's somewhere in between 0 and 1. And then the other root is somewhere between 3 and 4, but I don't know what they are. Yeah, exactly. I agree with you, Sophia. I say, I know one of them is -1, but I'm not too sure about these other two. How can I find that out? Well, here's what I would do, okay? I would take my polynomial, x cubed minus 3x squared minus 3x plus 1, and I would long divide it by x plus 1. Why did I choose x plus 1, by the way? Well, because one of my roots was at -1. So what goes into the parentheses? X plus 1. Yeah, that's why. Right, and you understand that, right? Okay, so let's long division this sucker out and see what we get. Okay, x plus 1, so I need to multiply this by x squared. This becomes x cubed. This becomes plus x squared. Subtract, subtract. There we go. This becomes -4x squared. This becomes 0. I'll drop down that -3x. I'm doing this kind of quick. I apologize, but all right. I've got to multiply this by -4x to make it happy. So then this becomes -4x squared minus 4x. Okay. And then I do a, did I do this right? Did I do this right? I don't see if I'm doing anything wrong. Something's, oh, no, I think this is going to work. Okay. So -3x plus 4x is x, and this is 0. So then this becomes x times 1. Gives me that. So then this is x plus 1. Drop down to 1. Cool. And that's 0. Awesome. Did I not change? I thought I changed the sign on every single one. Oh, maybe not that one. Okay. Yeah, I think that's, I mean, yeah. All right. Can I erase this stuff down here? It's just in my way. All right. It wasn't that hard, and it was just long division. We did like 4 of these long division problems already, so. So what I'm saying is, if I could definitely say for sure that one of the factors is x minus 1, or at -1, so I can say it's at x plus 1 or x squared minus 4x plus 1. All right, here's the thing. We need to factor this in order to figure out what those other 2 roots are. Those other 2 roots are hidden in here. The problem is we don't have a formula. Or we don't have a formula to give us all the roots of this, but we definitely know a formula to give us all the roots of this. Ideally, we would want to be able to do this. I'll tell you right now that that doesn't work. So we need to turn to the quadratic equation to figure out the roots of this. I'm sorry, I erased a little bit of it. Well, that's pretty straightforward. So figuring out the roots of that is just taking this and plugging it into the quadratic equation. So I have 4 plus or minus the square root of 16 minus 4 divided by 2. So that would be 4 plus or minus the square root of 16 minus 4 is 12 over 2. Okay. Hey, someone, what is the square root of 12? That's just like 3. 3 point something. What's the square root of 12? 3.5? Okay, cool. So I have 4 plus or minus 3.5 divided by 2. Okay. What is 4 plus 3.5 divided by 2? Oh, wait. What is the square root of 12? You guys have the calculator. I don't have one. You can see I've got a little paper and a clock. Oh, 3.46. Yeah, all right, fine. What is 4 plus 3.46? 7.46. Divide that by 2 for me. $3.73. Okay, that's one of my answers. And then what is 4 minus 3.46? Okay, divide that by 2. .27. Okay, 0.27. So I'm going to erase this quadratic equation part. So I would venture to say that if I had x plus 1 times x minus 3.46 times x minus 0.27, that was my answer. Or that's, I got these numbers from the quadratic equation because those were my other factors. And then if you look at the graph, oh, excuse me, sorry. If you look at the graph, I know it's a little bit backwards because well, I can actually switch to the screen. There we go. If you look at the graph, there you see it crosses at -1. But would you guys be able to kind of verify that that's about 2.27? I could hang with that. And then this is about 3.46. Wait, was it 3.46 or was it 3.73? Let me look at your comments. What was it? Oh, 3.73. Sorry about that. Yeah, because I'm looking at this, I'm like, that's not 3.46. Are you kidding me? But 3.73, I would agree with that, definitely, for sure. So, that's what Chapter 6 is. Chapter 6 is really just taking all the skills that you learn and putting them all together. That's it, really. It's not that hard. Actually, I'm looking at this. I don't think I teach you anything new in Chapter 6. Seriously. I think all I do is just ask you to take all the skills you learned from chapters 1, 2, 3, 4, and 5, or polynomial 1, 2, 3, 4, and 5, and combine all of those skills. Yeah, I'm done. Do you guys want to end now, or do you want me to do one more problem? Sounds like you're tired. Okay, can I just talk about one with you real quick? I'm looking at this one. Oh wait, you can't see that correctly. I'm looking at this one right here. Okay? You guys see it? All right, write it down for me. Okay. It's an x4th function, and this is actually the, actually, wait, I don't want to look at that one. I don't want to look at that one. I'm looking at it now. I'm looking at Oh, okay, maybe that might be weird. All right, fine, I can look at that one. I'm looking at this one. And this is an x to the fourth power function, okay? And I would definitely say, okay, all of these you can answer, but this one right here where we're using long division, I would definitely say I can see two roots for sure. One at x equals positive 2 and one at x equals negative 3. We cool? So what I would do is I would say, okay, well my original problem was x4 plus x cubed minus 2x squared plus 4x minus 24. And I want to divide that by, and I know two roots instead of just one of them. So what I would do is I would do this in two different ways. One of my roots is at x plus 3, and one of my other roots is at x minus 2. And then I still got to figure out what's left over. Are we cool with that? You can tell by looking at the graph. So these would be my two roots that I can definitely see, and the rest I don't know. What I would do is I would probably do long division twice, and I would just take this and put it here and long divide x plus 3 into here. And then I'll take my answer and I'll long divide the x minus 2 and see what happens. That's what I would do. I think that would be the easiest way. There's one way where you can do it where you don't have to long divide twice at all. You can actually use long division once, and it will give you the squiggly line. It will give you what's in here. That's if you divide it by x cubed minus x minus 6. If you long divide this into this, you'll go straight into this answer. Well, oh, I'm sorry, x cubed plus x minus 6. I'm sorry, screwed that up. Because what I did was I said, okay, if this times this times this gives you this, right? I'm sorry, not x cubed. I'm keep screwing this up. It's x squared. Sorry. Do you see it now? Oh, okay. Well, it's because all I did was I took these two numbers and I multiplied them together, and I'm dividing all of it out one time. And when I FOIL this, I don't know why I had so much trouble foiling that in my head, but this is what you get. So if I use long division on this thing and divided it into that, then it would take care of everything in one fell swoop. If that bugs you, then just do the ones we did before, but just do it twice. All right, anyway, Lucas, you are super late because we're done. Sorry. Yeah, Sophia, what you could do this in two ways. You could take this thing right here and divide it by that, and then take whatever your answer is and divide it by that. Or you could just do it in one fell swoop and take this thing and divide it by that monster right there. And it really isn't that much harder if you divide by that. You just have to, again, be very systematic with your approach, do all of the steps correctly, and if you do that, you'll be all right. All right, I'm going to end the class. How long will chem be?